This is the contains duplicate question. So you imagine that if you've got four numbers like 1, 2, 3, and 3, you want to see if there's a duplicate in this. If you use your eyes, you can clearly see that there is a duplicate of the number 3. So you gotta find the duplicate. Is there a duplicate in this list? So how do you do that? It's pretty easy, fellas. So if you got 1, 2, 3, 3, so you kind of want to loop through, you want to loop through the list, and then for every element, you want to make sure that an element of this number has not appeared any time before, So let's say you check 1, you want to make sure that anything that comes before this index doesn't have 1. Well, obviously, this is the first number of the list. It's not going to have it. And then you go to 2, and then you check, is there a 2? Have we seen a 2 before? Oh, clearly not. And then you check 3, and then you go, have we seen a 3 before? Or, well, clearly not. And then you go 3 again, and then it's like, well, have we seen a 3 before? Hey, check it out. We got a 3 there. So we got to have some way of remembering what came before. And you want to be able to look it up fast. Like, have we seen the 3 before? So the easiest way to do this is using a hash map, or in this case, I'm going to be using a set. If you make a set called scene, so what you want to do is like you loop through this, and then you go, hey, have we seen the number 1 before in our set? So let's write a little bit of pseudocode for num in nums, right? Have we seen num before? If num in scene means we have seen this number before, which means that we found a duplicate, so we can return true. Yeah, we found a duplicate. Otherwise, well, then that's the first time we've seen it. So like in this case, the first time we've seen the number 1. Then you can go scene.add num. Right, so you're gonna loop through each one, and then you're gonna perform these checks. And by the end of it, if you've passed through this and you did not find a duplicate, then you can safely conclude that there is no duplicates in this list. So this is just generally the code. It's pretty simple. This is just a very simple hash map question, and we can try it out in the code. So we're gonna make our little set. We're gonna call it scene, as per discussion. And then we're gonna write a little for loop for num in nums, for every number in the list of nums. If this specific number, if we've seen this specific number, right? If num in scene, then we return true. Means we found a duplicate. If otherwise, otherwise the number that we're looking at is not in the set scene, it means this is a new number. So we're gonna add that number into the scene set. And then that's it. And then at the end, we go, well, if we've processed every element and we didn't find a duplicate, then we can conclude that there are no duplicates inside this list. Anyways, let's try running this. Whoa, it's correct. Holy shit, I'm smart. Yeah. That's pretty good. Alright, in terms of time complexity, time and space complexity, what do we got? Time complexity, we're gonna loop through each element exactly once. So we can say pretty straightforwardly that the time complexity is an O of n, where n is the length of the nums list. Space complexity, well, the only extra memory that we're using is this set here. This set grows as large as the number of unique elements there are inside the nums list, right? So in the worst case scenario, where every number is unique, the set is the size of nums. So in the worst case, we can say that the space is O of n. Well, obviously, if it's the best case where every number is a duplicate, then scene would be very, very small. But I'm just going to say the worst case. So the time and space complexity are both O of n, and that's the solution. Yeah. Do you understand? If you don't understand, I'm gonna beat the fuck out of you. I'm just kidding. I would never do that. Okay, bye.